Okay, welcome back. So we're looking at measuring power levels as a function of the position of the piston, and we're going to look at the piston, and we're going to line the piston up so that here is the channel bringing radio frequency energy from piston transceiver 1 through the wall of the piston, and then out through the wall of the cylinder, and then to the cylinder wall transceiver sitting at position E. And right now we've got it set at a 100% opening. This is all completely lined up, and when we did that and we measured some values, we found that the value basically was a level of 10 when the opening was at 100%. And we put a couple of different points here to demonstrate that the power level will be in the zone of what we're calling 10, but it might not be exactly 10. And that's just because whenever you're doing measurements with measurement equipment, there's going to be some variability of the result that you get. But here is our little graph that we had before that's showing when the opening is set at a 100% opening level, that we get power values of 10 for this 100%. And the question becomes, well, what happens if this opening changes? And so what we'll do is we'll go turn off this full beam power for E. So it was coming out because it was completely lined up, but we've turned it off so that we can see in there. And we'll go over here and grab a hold of this piston and make the statement that the piston moved a little bit, and we're going to make an estimation, and there's no need to measure it, we'll just make an estimation. We're going to make the estimation that the doorway of the opening between the piston channel, the piston wall channel, and the cylinder wall channel has moved. The piston has moved some, so that this doorway is now at a 50% opening. And the question is, if this doorway, now you'll notice there's a little bit of some energy that's going to come out on cylinder wall transceiver D. We'll get back to that. But what we're really talking about right now is simply cylinder wall transceiver E. That's what we were measuring before. And we can see that we have a data point that's floating. So we'll put, all right, so we got this data point where it's supposed to be. Let's take a look now, and since this doorway is halfway opening, the E transceiver is going to be at half power. So instead of coming out like it was to this level of power, it's going to come out at less power, full power, less power, because the door is halfway closed. And the prediction that we'll make is the little data points when we measure it, when we actually physically measure it, because we forced the doorway to be at 50% open, and we asked the device to measure what was there. And we'll get a value of, we think, about 1/2 of what it is when it's fully open. And the same exact relationship is going to happen where some of the values will be exactly at this arbitrary number of 5, but some of them might be 5.2, and some of them might be 4.8. But we're going to see that for the most part, when we start repeatedly measuring this using all of the variabilities that we use to establish the concepts of measurement and prediction, which is that we turn the power on and off, and we open and close the gate, and we go downstairs, and we come back, and we do all the variability that constitutes proper measurement. And after a while, we'll get a collection of points that shows that when the doorway is 50% open, that we're going to have an arbitrary power level of about 1/2 of what it was when the door was 100% open. This is our prediction.